Welcome back to my channel Whiteboard e-learning. Dear student, this will be the last video of this chapter, that is the motion and time. And in this video, already in my previous Google Meet class, I have described the last thing, that is the how to plot a graph. Mainly this type of graph, line graph, which is I am now highlighting. So for plot a graph of any two variables like distance time or speed time. So time axis you have to take along x-axis and dependable variable you have to take on y-axis. But I have told you we are just now using this quadrant, first quadrant, because time is positive here and also we have taken the distance and speed also positive here. So if these are negative, then other quadrant we have to take, but in this situation in the lower classes, so always we take the first quadrant, that means the positive x-axis and the positive y-axis, which already the NCERT has been highlighted in the of red color. Okay, now these are the data we have to plot. So our main theme today, how to plot a graph. So it is very important. Maximum students, those who are reading in the higher classes, they also don't know how to plot a graph. So it is very important, very tough also, but I will make you understand with a simpler method, and I hope that you will understand that. You can see this is the table containing the time and distance of a particular car has moved at a particular time, how much the distance the car has been moved, it is written. So serial number 1 2 3 4 5 6 0 0, at 0 time 0 distance covered, 1 minute 1 kilometer covered, 2 minute 2 kilometer covered, and so on in this way. So what to do? Already NCERT has written what is written here. I will not read each and every between the lines today, so it will consume time. So I'll give you some points. You have to remember that. First of all, you have to buy 1 millimeter graph paper. Okay, and on the graph paper you can see probably just like this type of small squares on positive x-axis and positive y-axis. Already I have drawn this graph on my computer and I will show you that also. So first of all, what to do? First of all, you have to take the 1 millimeter graph paper, and it looks like this one. You can see this is the graph paper, and first of all, this is the origin where the x-axis and y-axis meets. This is nothing but the origin. Okay, so this x-axis we have treated, this is the time axis here, and you can see in my data, if I go to my data, then you can see this is the data, time and distance, 0 1 2 3 4 5, it is also 0 1 2 3 4 5. So it is not very difficult to remember. So now again go to the graph. So time 1 2 3 4 5, 0, this is 0 1 2 3 4 5 in the x-axis we have taken, and in the y-axis we have taken 0 1 2 3 4 5, that is distance. So now why we have taken up to, you can see here also, if you just notice the bigger square here are there. So this is big square. You can see inside the big square some small square also there, 1 2 3 4 5, and in this way in the vertical axis it will be also, along y-axis it is also 5. So total 5 into 5, 25 small squares in a big squares, inside a big squares. Okay, so first of all, what to do? First of all, which is very important in this topic, if you want to draw a graph, then you have to choose a suitable scale. It is very important. So again I am going to NCERT book, and you can see it is written here. These points you have to remember. These points. What are the points? You can see here it is written. Some of the points to be kept in mind while choosing the most suitable scale for drawing a graph. How do you choose the scale? So what you have to keep in your mind, that is the time, the difference between the highest and the lowest values of each quantity. So that's why we have seen highest value in the graph was 5. Again we have to go to the show difference between the highest and the lowest values. Then you can see what is the highest value in the data. We have taken one data. In the time axis you can see 0 is the lowest value and 5 is the highest value, is not it? So you have to take the difference 5 minus 0, how much? 5. Then 5 minus 0, how much? 5. Then I have divided by 10. Why I have divided this 10? Because in the x-axis, because time axis is taken in the x-axis actually. So how many big squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why I have divided in the 10. Also we can divide this up to 9 squares, up to 8 squares, whatever maybe you may take, but which will be consistent graph, which will be acceptable graph. Because if we divide 5 minus 0 by 10, if we take the 10 squares, big squares, then it will come out as 0.5. It is a fair value. Because if you take, what is 0.5? So 1 square in the x-axis, that is the t-axis, it will be 0.5. Then it will be double of 0.51. Then it will be triple of 0.5. It is 1.5. It is 2. It is 2.5. It is 3. It is 3.5. So what is 0.5? 0.5 is the division, is the smallest division. Actually it is not the smallest, the square length of the square along the t-axis, 0.5, 0.5, 0.5, 0.5, in this way. So it is 2.5, then 3, then 3.5, then 4, then 4.5, then 5, in this way. So as it is the consistent and fair value, we have taken and registered. Now along y-axis, again you can see in the y-axis what is written. Y-axis we have taken the distance axis. What is the highest value? 5 is the highest value. What is the lowest value? 0 is the lowest value. Then what is the difference? 5 minus 0. What will be? That is again 5. Okay. And we have divided the difference in the x-axis, the highest value and the lowest value, we have divided in the 5. Why we have not taken total square? 1, 2, 3, 4, 5, 6, 7. If we divide by 7, you can see 5 minus 0 by 7, it will comes out as 0.714. So it is not a easy value, simple value which will facilitate our calculation. That's why we have neglected it. We can accept it, no problem at all. We can do the calculation, we can make the graph, not a problem actually. It will be just a difficult value will come, not more than that. We can take that. But for simplicity, we have deducted, we have just neglected this value 7. So if the students can ask again one question, why we have not taken 6? Yes, you can take 6. 1, 2, 3, 4, 5, 6, up to 6. 6 big squares you have taken. Yes, you can take that. Then again it will come out as 0.83, which is not the fair value. If it is come 0.51, then it is easy to calculate. That's why we have taken up to 5. In the y-axis, in the distance axis, you have to write in this way. If we divide it 5, if we take total 1, 2, 3, 4, 5 square, then you can see 5 minus 0, the higher value in the axis, 5, lower value, it is 0, I have not written here. So 5 minus 0, 5 by 5 is 1. So we have given tick here because it is acceptable value here. And that's why we have taken along x-axis, along t-axis, 0.5 second is the smallest value. Okay, it is 0.5, it is 1, it is 2, in this way. In the y-axis, we have taken smallest value, taking the big squares. So 1, this is 1, this is 2, this is 3, this is 4, this is 5. Now after that, what you have to do? Again we are going to the NCERT book. You have to do, already the NCERT book has done. So 1, this 1. So at the 1 point, what we have taken the 1 along the t-axis, you have to take that point and going upward. And on the 1 in the y-axis, you have to take one parallel line in the x-axis. Then it will meet at this point. So this point you have to encircle. Then 2, this 2. So how to do that? At the point 2 on the t-axis, that is the x-axis, you have to draw one vertical line along x-axis, and at the 2 point you have to draw one horizontal line which will intersect at this point. We have encircled it. How we have encircled it? So the next figure shows that in this way you have to encircle it. Here one encircling point will be there. This is a fourth point, it will be the fifth point. And you can see in the graph, in this way, the first point we got this one, first point. These two, intersecting point. This is the second point on the graph. This is the third point, fourth point, and so on. And we have connected all the point by a line. And that is the final, we have got the nature of the graph. That is a straight line passing through the origin. So up to that we have learned. So what you have to write here? You have to write on the graph, it is the t-axis, it is distance axis. Scale point, what scale you have chosen here, you have to write on the top of the graph. That is the one's smallest division or one small square, one's big square we have taken along t-axis, that is 0.5. One big square we have taken in the y-axis, that is 1 meter. I think it will be meter. What was the previous value in the table? Yes, no, kilometer. So it will be kilometer. So you have to write in the graph distance in kilometer and time in minute. Okay, in this way you have to proceed. And the second point we have not covered now. So what will be the second point? Yes, this first point, is it clear to you? I have done so many information on that. Now the intermediate values of each quantity, so that with the scale chosen it is convenient to mark the values on the graph. So you can see these are the not convenient values. That's why we have neglected this value. Y value we have not divided in the y-axis 6 big squares because this is not convenient value. Why we have not chosen, we have not divided by 7 big squares, because if we divide by 7 big squares then it will come out as 0.714, which is not convenient value. So that's why we have chosen up to 5 and it comes out as 1, which is very much convenient with the previous value, with respect to the previous value. But you have to keep in your mind the third points, which is also very important. What is the third point? It is the third point, to utilize the maximum part of the paper on which the graph is to be drawn. Yes, after drawing the graph, you can see, if you see, the graph is very small with respect to the total area of the graph. Your graph is confined to this small area. Suppose this small area your graph is confined, then it is not good graph. It will be not consistent graph also. So you have to keep in your mind that maximum graph paper you have to utilize. I think I have make you understand some points, and if you have any problem to draw any graph about this, how to choose the scale, then you can call me, no problem at all. So now we'll go to the chapter end exercise, and it was all about the graphs I have told you. Now the chapter end exercise. Now classify the following as along the straight line, circular or oscillating motion. So remember, motion of your hands while running, it is oscillating motion. Motion of a horse pulling a cart in a straight road, it is a straight line motion. Motion of a child in a merry-go-round, sorry, it will be a circular motion. Motion of a child on a seesaw, motion of a child in a seesaw, it will be a oscillating motion. I think it will be oscillating motion. So you can see here, motion of a child in a seesaw, oscillating motion. Okay, now go to the motion of hammer on electric bell, it is also oscillating motion. Motion of a train on a straight line, straight bridge, it will be a straight line motion. Now which of the following are not correct? The basic unit of time is second, it is correct. Every object moves with a constant speed, it is not correct. Distance between two cities are measured in kilometer, correct. The time period of a given pendulum is constant, it is also correct. The speed of a train is expressed in meter per hour, not correct. The simple pendulum takes 32 seconds to complete 20 oscillation. What is the time period of the pendulum? What will be the time period of the pendulum? So what is time period? Time period is nothing but the time taken to complete one oscillation. How many oscillations are there? 20 oscillations. Then you have to divide 32 by 20. It will comes out as 32 by 20, 1.6 seconds. But you can see here the answers are given in the seconds. Don't write it in seconds. I have told you unit of any physical quantity must be expressed in singular, not in plural. So they have added seconds, s. So don't write seconds, only write small s instead of seconds. Remember these things in your mind, because in your exam if you write seconds, then some marks will be deducted and it will be 0.5 marks will be deducted. Now go to the question number 4. The distance between the two stations is 240 km. A train takes 4 hours to cover the distance. Calculate the speed of the train. Then you know what is the definition. Speed is equal to distance by time. So distance is 240 by 4 hours and it will comes out as 60 km per hour. So it is written here, distance covered by time taken 60 km per hour. As the question asked in kilometer per hour, so you can give the answer in kilometer per hour. But you know, we have to express all answers. We have to write in SI unit. I have told you that is distance unit will be in meter and time unit will be in second. But no need to convert it 60 km as the question asked it, question given in kilometer and hours. So that's why you have given the answer in kilometer per hour. No problem at all. Now go to the question number 5. The odometer of a car reads 57321.0 km when the clock shows the time 8:30 am and 8:50 am it shows 57336.0 km. So what is the difference in odometer? What is the difference in time? That is the time taken by distance covered. So calculate the speed of the car in kilometer per minute. It is also written. So as the question asks kilometer per minute, so you have to express that in kilometer per minute, and finally you have to express it in kilometer per hour also. So what will be the answer? So you can check it back here. So distance covered, so final value of the odometer minus initial value of the odometer, that is 15 km, and time taken 8:30 minus 8:50, final time 8:50, initial time 8:30, so it is 20 minutes. So 20 minutes we have to convert it in hour, that is 1/3 hour. So speed in kilometer per minute, what will be? Distance covered by time taken. So kilometer I have 15 and time, that is 20 minutes, 0.7 km per minute. But we have to express it in kilometer per hour, then kilometer, and in the place of minute we have written, we have already converted it 1/3 hour. So we have written and it is 45 km per hour. Now question number 6. Salma takes 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of 2 meters per second, calculate the distance between the house and the school. It is also very easy, and you know distance is nothing but if speed and time are given, then you can find out the distance by just distance is equal to speed into time. Speed is written here 2 meters per second and time is given here in 15 minutes. Dear student, this type of numerical problem will come in your exam, and you may make mistake in this type of question. Generally students will multiply 2 with this 15, then it will comes out as 30. But what will be the unit? No, unit will be different if you write it meter, because you have not converted 15 minutes into seconds. So as it is given 20 meter per second, already you have to convert the time in also in seconds. So what is 15 minutes into seconds? So that will be 15 into 60 seconds. So 15 into 60 into 2 will be your answer. So see the answer here. 15 minutes, 50 into 60, it is 900 seconds. So in the question don't write seconds, it will be, instead of that you should write only s. Now distance will be speed into time, so 2 into 900, 1800 meter, and you know 1000 meter is equal to 1 kilometer. So divided by 1000, it will give you as 1.8 kilometer. So if you write only 1800 meter, then that will be also correct answer. Now go to the next question. show the shape of the distance time graph for the motion in a following cases. A car moves with a constant speed. A car parked on the straight side road. What will be? So the answer will be here. You can see the time is moving and the distance is increasing, and in each and every interval of time, distance also increase in each and equal interval. So that is nothing but the uniform motion. So in the uniform motion, it will be a straight line passing through origin, and the car parked on a straight side road, then each and every time the distance will be equal. Distance, there is no change in distance. So 1 second, this is the distance. 2 second, same distance. 3 second, that is same distance maintained. So it will be a straight line with the t-axis. Now go to the question number 8. Which of the following relations is correct? Speed is equal to distance into time. Speed is equal to, no, it is incorrect. Speed is distance by, it is correct. Speed is equal to time by distance. No. Speed is equal to, no. So second options will be the answers. So second answer, speed is equal to distance by time. You know that. Now question number 9. What is the question number 9? The basic unit of speed is kilometer per minute, meter per minute, kilometer per hour, meter per second. Yes, I have told you, you have to always you have to follow the SI system that was previously known as the MK system, meter, kilogram and second. So if it is written in meter per second, that will be a correct answer. A car moves with a speed of 40 km per hour 15 minutes and then with a speed of 60 km per hour for the next 15 minutes. The total distance covered by the car. So total distance means speed into time. So speed into time you have to multiply. Again speed into time, because two different speeds are given. Then you have to add them up. Then you will get the answer. But before that you have to convert it. It is written what? 40 km per hour. So time is given in the hour. It is written, time is given, written hour, given minutes. So you have to convert these minutes into hour, and you also convert this minute into hour. Then you have to multiply and then add up. Now you will get the answer here. 40 km per hour, time 15 minutes. So 15 minutes we have to convert it into hour. 15 by 60, 10 km, and already we have, it will be 15 by 60 into 60. So 60 into 15 by 60, 15 km. So it is 10 km, it is 15 km. So total distance covered 10 plus 15, 25 km. Now question number 11. Suppose the two photographs shown in the figure 13.1 and 13.2 had taken at an interval of 10 seconds. If a distance of 100 meter is shown by 1 centimeter in this photograph, calculate the speed of the fastest car. Okay, now we are going to the answers. So you think, suppose the two photographs shown in 13.1 and 13.2 had been taken at an interval of 10 seconds. If the distance 100 meters is shown in 1 centimeter, then what will be the fastest car? Here it is written 1 centimeter this photograph. Calculate the speed of the blue car. It is written, it is not written here blue car. Speed of the fastest car. So each and every car, if you want to calculate the speed, then the initial position and final position you have to take. Then you have to measure it by your scale, and each and every centimeter they have taken as 100 meter. You have to multiply. Then you have to find out these answers. If we just take for as for example, if you take the blue car, then what is the distance of the blue car? That's why we have drawn here 1 point, and after 10 seconds the blue car has progressed, traversed this distance. So midpoint of the car we have to take the distance. So what is the distance from this to that? You have to find it out, and it is showing that it is 2 centimeters. So each and every centimeter is 100 meters. So 2 centimeter will be 200 meter. Okay, and it is taking 10 seconds to travel that point, that distance. So distance is equal to 200 meter, and time taken already given by the NCERT book, that is the 10 seconds. So 20 meter per second will be the answer. Now go to the next question. Figure 13.15 shows the distance time graph of the motion of the two vehicles A and B, which one of them is moving faster? It is very important question. I have given this question so many years in the class 7. And you know, distance time. So this one and this one. Okay, I have drawn one vertical line from a point on the A graph, any point on the A graph, and now, okay, and this one. Okay, so we have fixed the time here. Suppose this is t time. Suppose it is t time. Okay, t time, and this is the distance. Suppose s1, and this is the distance s2. So this is s2 and this is s1. So which is greater? At that time, in a particular time, which vehicle traveled more distances? So here s2 is greater than s1. So s2 is for A. Okay, so A vehicle has moved more distance with respect to B. So in this way you can give the answer in the answer sheet. And another way also is there, slope of the graph. Which graph has more slope? Slope means with steeper graph. Which is the steeper graph? A is the steeper graph. Which is the steeper graph? That is the vehicle moving with the faster speed. You know, steeper means it will make an angle with the t-axis. If it makes more angle with the t-axis, means its speed is greater. Okay, now go to the second question, that is, which of the following distance time graph shows truck moving with a speed which is not constant? And answer of this, you can see these are the graphs, and what will be the answer? 3 graph is not a straight line. You can see 3 graph is not a straight line, so it shows a truck moving with a speed which is not constant. So we have to again go back to the question. What is the question first? Once again read it. Which of the following distance time graph shows a truck moving with a speed which is not constant? So it is a distance time graph. From the distance time graph you have to find out the speed. So we can see a time increasing, distance is also increasing, so speed is constant. Here time is distance is also constant. That means in the distance covered it not changing. That means the body in the rest condition is not constant, so it is constant. It is also constant. It is also speed. What is the speed? Zero speed here. So if the 0 is a value, then it is constant, 0 0 0 0. And here also the distance by time, if you just divide throughout the motion, the speed will be constant here. So these are the constant examples, constant speed example. Now you can see this one, time increases, distance also increases, but distance are not increases in a equal amount. It is increasing more, so speed is increasing. So it is not actually the example of constant speed. It will be a different speed. And now distance and time, you can see it is also constant. Time increasing, distance also increasing, and you can see equal interval of time the body moved equal distances. It is showing by a straight line graph. It is coming for that graph which traverses equal distances and equal interval of time. So it is confirmed that it is a uniform speed. So which is not uniform speed? Which is the example? Example will be graph is not a straight line. As if the graph is not straight line, that means each and every time, equal interval of time, the body moves different distances and it is increasing. That's why it is not a constant speed. It is a non-uniform motion. Okay, and non-uniform motion leads to non-uniform speed. Okay. Thank you for watching my video. If you think video is helpful to you, don't forget to hit the like button and subscribe my channel for next upcoming videos. Thank you.